Hi, everyone. So yeah, this is my session. Welcome to the jungle, a safari through the JVM landscape. And shortly, some words about me. So I'm Gerrit Gruwald, working for Azul as a senior developer advocate. I'm a JAG leader, Java champion, do Java since, I don't know, 20 years. And I love it. And the reason for this session is that we have so many different distributions available that I was really wondering which one to choose. That's the main idea. And everything starts with OpenJDK, right? So probably all of you know that. And the definition is it's a free and open source implementation of the Java Platform Standard Edition, or shortly Java SE. And it has its own website where you can find stuff, everything about OpenJDK, which is https://openjdk.org, or you can scan this QR code to go there. And even the source code is available on the web. So, and you can find it on GitHub since JDK 16, and there was a specific project to move it to GitHub. It was at Mercurial repository before, and then Oracle decided to put that onto GitHub, and there you will find it on github.com openjdk/jdk. So if you would like to check the source code, you can get it there, you can fork it, you can build it, whatever you like. And that directly leads me to the next point, which is the contributors. Because you might guess, if you talk to people, many people just say, oh, OpenJDK, that's this Oracle thing. That's not really correct, right? So it's not only an Oracle thing, because there are a lot of different contributors to the OpenJDK project, as you can see on this list. It's like Amazon, like Azul, ARM, Google, Microsoft, Oracle, of course, Red Hat, SAP, JetBrains, you name it. So you see, it's a lot of companies and individuals that contributing to OpenJDK. And this is a good sign because it shows the interest in the platform and the interest on these big companies to move that thing forward, right? So that gives you some kind of safety because, you know, okay, it's not just me. And also, it's not a one-man show. So we are not really relying on one company because all of these companies contributing to the OpenJDK project, which is great. And now the interesting part is a little bit the roadmap. So that means, how is the release cadence of OpenJDK? So first of all, this changed in the past. So let's take a look at the old release cadence, right? We go back to JDK 6. And that was in 2006. And then it took 4.5 years until we got JDK 7, which is a long time, right? And then from JDK 7, which was big at that time, to JDK 8, which was even bigger, that only took 3 years. I mean, only, it's still 3 years. And that means we had to wait multiple years before we could test the new JDK. That was not really nice, to say it like that. And that was one of the reasons why that was changed to the new release cadence. And the new release cadence looks like this. And you see it's a lot of more releases now. So we have every 6 months here, we have these new versions coming out, right? So and you see that we have this pink circles here, like 11 and 17 and 21. And this is the so-called LTS releases, right? And that means long-term support versions. But between them, we have now, from version 9 on, we have 9, 10, 11, and every 6 months, now we get a new version, a new Java JDK. And that means now you can test the new JDK every 6 months instead of a couple of years waiting between them, which is really great, right? So this is the new release cadence. And it was a challenge for some companies because in the past, it was like, oh, I'm on JDK 6. That's fine. And you could stick on JDK 6 for years and it was okay, right? So you just got updates. Now it's like you can be on 9, you can be on 11. Probably you should use the LTS ones, but you could be on 8, 11, 17, whatever. And it's a lot of, you have to adapt to this new release cadence, which took some time for the people to really got that. But I think it's a good idea that we have that. It really helps. And to get a better understanding of what the OpenJDK contains, that's in principle, it's the JVM, right? So the Java virtual machine. And to get a better understanding of that, just like let's take a short look at the internals, right? The internal structure of the Java virtual machine. We have three separate blocks here. We have the class loader subsystem, the JVM memory, and the so-called execution engine. And these are three blocks. And of course, this is not just this class loader subsystem, but if we take a closer look, then we see it contains the loading part, where we have the bootstrap class loader, extension class loader, the application class loader, and then we have the linking part with verification, preparation, and resolution. And then we have also initialization part. And you see this is very modular. So we have lots of different things only in the class loader. So if we take a look at the JVM memory, this continues. So we have the method area, the heap, the stack, the PC register, and we also have the native method stack. So that you see there's a lot of different things that are separated in these three blocks. And then inside, again, it's separated in different parts. And for us, the most interesting part is the execution engine. And the reason for that is it contains the interpreter, the compilers, so that means the JIT compilers, and the profiler, and also all the garbage collectors. Plus, it has the native method interface, and it has native method libraries. So this is in principle an abstract view of the JVM internal structure. So in principle, it's an abstract computing machine. And we come to that a little bit later because we need this information to dig into special things or special JDK versions. So, and this is exactly the thing I would like to talk about next is there's a JDK and there's a so-called JRE, right? Which should be obvious to most of the developers, but still it's interesting to see. So it's the JDK, which is the Java Development Kit. And then we have the JRE, which is the Java Runtime Environment. So and if we take a closer look at how this is structured, then the JRE, the runtime environment only contains the JVM and the class libraries. So that's all you need to run a Java program. But if you take a look at the JDK, then it's a superset of the JRE, plus it also contains the Java C compiler, the debugger, Javadoc, and other stuff. So the recommendation in usage is if you are below JDK 9, then usually you should use the JDK for development. And in production, you should use the JRE. The reason for that is that the JRE is smaller. So if you run, for example, a microservice environment, you would like to keep the Java installation as small as possible. So you should use the JRE instead of the JDK, because the JDK contains stuff that you need to debug and compile things, but you don't need that in production, right? If you, on the other side, go above JDK 8, so that means JDK 9, 10, 11, whatever, then there is no JRE really. So what you then should use, you should use the JDK for development and the JLink build for the production. So the JLink is a tool which makes it possible to really create a custom Java runtime image, because now the JVM or the JDK is modular, so it only contains the modules that you need for your application. So it could be even smaller than the JRE. So right, so the recommendation for everything bigger than JDK 8, use a JLink build for production because it could be smaller. And now the most interesting thing is distributions, because we have lots of them. And I structured them in two different parts. So the first thing is the builds of OpenJDK. So I told you that OpenJDK is in principle just the source code. So if people say, I'm running on OpenJDK, that doesn't mean anything, because OpenJDK is just the source. So you have to say something like, I'm running on Oracle OpenJDK, or I'm running on Zulu, which is a build of OpenJDK, right? So this is the way how you should describe it. And if we take a look at the distributions, then you will see this is a list of distributions. This is all builds of OpenJDK. You see, this is a lot, right? It's many, many, many. And in this case, you see things like adopt OpenJDK, which is dead because now we have Xamarin. You see the same for OJDK build, which was a build of the Red Hat stuff by the community, which is also dead, not supported anymore. We have Oracle JDK, we have Oracle OpenJDK, we have Zulu, Platform Prime, which is from Azul, Xamarin Certified from IBM, and so on. So we have 20 different distributions. So the question is which one to use, right? But before we come to that, there's also GraalVM. This is not really OpenJDK, but still I put it into this presentation because it's used and it's there, and it can run Java programs in the same way. So build of GraalVM, yeah, also here we have different ones. We have Glue on GraalVM, we have two different ones from Oracle, which is the community and the enterprise edition. Liberica Native Image Kit, and Mandrel, which is from Red Hat. So again, the biggest question is which one to choose. This is really a problem. It's not easy. We have all these different things, right? 20 distributions of OpenJDK builds. And I told you OpenJDK is just the source code. So what is the difference, right? The question is, are there any differences? And if there are differences, what are the differences? So here's a little list of differences that can help making a decision. First of all, is the term of support or support term, and then the updates that are available, the compliance of the distribution, the cost, and the performance could make a difference, and also additional features, for example, and alternatives to the standard, right? So this all can be differences, and we will look shortly in all of these points now. And I try to cover everything I found out, and I hope it helps you. So the first thing is the support term or term of support. So we have different ones. We have, first of all, the STS, which is the short-term support. And then we have the LTS, which is the long-term support. And if we take a look at all the different releases so that we see here from JDK 9 to JDK 21, and we take a look at the short-term and long-term support versions, then it's like this. So the pink ones are the long-term support versions, where the white ones are the short-term support versions. And short-term support is only from one to the next one. So that means when JDK 10 comes out, the support for JDK 9 is done. That's it, right? But if you go to a long-term stable or long-term support version like the LTS 1.11, that means you could get extended support until September 2026. And that depends on the vendor. So companies like Azul offer even more extended support than Oracle does, and also other companies do that. So and you see here, the problem that if you go with an STS release, so you could go to, let's say, JDK 14, because there was a feature in and you would like to use it, it was JPackage, for example, you would like to use that in your application. The problem is as soon as JDK 15 comes out, the support for JDK 14 stops. And the problem that comes with that is you now have to go to JDK 15 if you like it or not, because you don't get any security updates or something. So you probably should stay on the LTS ones. So to make it short, short-term support releases only for 6 months. Keep that in mind. And the difference it makes between the distributions is that not every distribution provides short-term support versions and long-term support versions. So that really depends. You have to take a look at that. Some of them only offer 8, 11, 17. No short-term support versions at all. So check that out before you make the decision, right? So, and the recommendation here is, of course, in development, you can use whatever short-term or long-term support versions, but in production, you should stick to long-term support versions, that's for sure. So the next thing when we talk about differences is the update strategy, right? Because we have different updates that are available for the different OpenJDK builds. For example, there's the so-called CPU, which is the critical patch update, and there is the PSU, which is the patch set update. And if we take a look at the structure, then the CPU only contains fixes for vulnerabilities or critical issues, and that's it. Where the PSU, again, is some kind of superset of the CPU, and the PSU also contains fixes for non-critical issues and new features. And this could introduce new issues. It doesn't have to be, but it can be, right? So, and that's if you only fix stuff from the last version to the new one, then the chance that you introduce new issues is lower than if you add even new features to this new stuff, right? And to make it more clear, I try to create a little graph because we have 4 times a year we get these updates. And the first one is, for example, in January. And for this example, 1701, on the upper bar, we see the PSU, which contains the CPU. And then there's a CPU update. And this only contains the critical fixes. So if we now go forward for 3 months, in April, the 1702 version comes out. And now the interesting part is that the 1702 CPU build only contains the fixes from the 1701 PSU. So that means feature-wise, you're always one step behind, but you're on the safe side. That's the main idea. And this continues. In July, we have the next build, and in October, we have the next build. So this is how it works with the updates over the year. And if we take a look at that, then the patch set updates are available from most of the available distributions. So I would say every or more or less every of these distributions will provide a patch set update. That means including the features. But the CPU ones, the critical patch updates, are only available from Azul, Bellsoft, and Oracle. And that's it. So my recommendation here is, if you are in development, just you shouldn't really don't care. You can use CPU and PSU, right? But if it comes to production, you only should use the CPU updates. If you're running mission critical stuff, the chance to introduce new issues is much lower if you just use CPU in production. Okay, so that was updates. Next point would be compliance, because if you have a JDK distribution or a build of OpenJDK, and you would like to name it Java SE compatible, you have to fulfill some tests. So it should be compliant to, for example, the so-called TCK, which is the Technology Compatibility Kit. And this is licensed by Oracle. So what is it? So it was originally developed by Sun Microsystems. It's intellectual property and licensed by Oracle. And for example, for JDK 11, it's more than 120,000 tests just for this one, for JDK 11. And all binaries must pass the TCK before they are allowed to be labeled Java SE compatible. So that means really every package should fulfill this test. Not only you say, oh, JDK 11.0.5 passes the TCK. No. Every package like Windows build, Mac ARM build, all of these have to pass the test. This is a lot of stuff, right? It's a lot of tests you have to fulfill just to get this label Java SE compatible. And what it's really about is the so-called Java Compatibility Kit, which is part of the TCK. And this contains, or it tests features that are likely to differ across implementations, or that rely on hardware operating system specific behavior, that are difficult to port, or either mask abstract hardware behavior or operating system behavior. So this is the tests that are featured in the JCK. Right? And the question is, how can you get access to the JCK? So in principle, this is free, but you must meet terms of the OCTLA, which is the OpenJDK Community TCK License Agreement. What a nice title. And in addition to that, you also have to sign the OCA, which is the Oracle Contributor Agreement. If you do all that, you can get access to the JCK, and then you can run all the tests against your own build of OpenJDK. And I made it in a list because it's different if you are TCK compliant to JDK 8 or to JDK 9 and above. So JDK 8, for example, this is a list I found. These distributions are TCK compliant related to JDK 8. And you will see that, for example, Dragonwell, which got the TCK compliance for JDK 8, is not on the list for JDK 9 and above. So it's not enough to say, oh yeah, Dragonwell is TCK compliant. Not every version. So you really have to check, right? And this stuff is also available on the web, so you can check that. But you see, it's not the same list that we saw before. It's smaller. So that means not every build of OpenJDK is TCK compliant. And the TCK compliance makes sure that your code really runs on that hardware for what you build the OpenJDK. And you would like to have that, right? So otherwise you never know if it works or not. But this is not all. There's another one, a new one, which is called the Aquavit. It's the Adoptium Quality Assurance and Vitality and Speed Test Suite. This is by Eclipse, and it came with the Adoptium project. And what it is, it ensures that all additional qualities are present that make it suitable for production use. So where the TCK tests the JDK itself, the Aquavit is more made for making sure that it really works reliable with application, real-world utilization patterns, security and durability tests, and all of that stuff. So it's more than 350,000 tests that are that will be used for this kind of test. And for the Aquavit compliance, you see the list is even smaller, right? We just have, in this case, only 7 distributions that really are compliant to the Aquavit. And it's only available from JDK 11 and above, so it's not for JDK 8. But you see, it's a smaller list of distributions. The recommendation here is for development, whatever you like, right? Just use whatever you like. Probably it will be the same that you also use for production, but in production, you should at least have something that is TCK compliant to really make sure that your code works, right? So you have to make sure that this is really the case. And that one leads me to the next point of differences, which is a very interesting one, cost. Because we are used to download Java for free, right? And there are free versions available, of course. We take a look at the list and you see, bam, it's huge. All of these distributions that you see on that list, you can download for free and use for free. No problem, right? You see, it's a lot. And that's fine. But what about the paid ones? Okay, if you need the paid ones, then the list is smaller. This is Azul Platform Prime or Platform Core, IBM Xamarin Certified, GraalVM Enterprise, and Oracle JDK. They are all based on number of cores. Wait a minute, something changed in January because Oracle had this nice idea to change the basis of the calculation from a core, counting the cores to calculating the cost to just number of employees. So which is a great idea because it's so much easier for them to calculate. But I just can warn you that you might run into trouble if you have a Java SE subscription with Oracle. You probably want to check if you apply to these new rules because that might be very expensive for you. And I have a shameless plug. We offer the same service and support for a fraction of the price, but that you can check out on our azul.com website. Okay, so, and keep in mind, this also is for GraalVM Enterprise and not only for Oracle JDK, which leads me to the next point, performance. Performance is an interesting thing because you saw we have 20 different distributions. And the question is, okay, if we have so many different ones and they are all builds of OpenJDK, where's the difference? And that's the reason why I first of all talk about baseline performance. Baseline performance is this list. Oh, not a big surprise because they're all builds of OpenJDK more or less, except the GraalVM builds, because GraalVM has its own JIT compiler, but performance-wise, it's more or less on par with the OpenJDK compiler. That means all of these distributions are more or less the same speed or performance with some exceptions, right? But if you really would like to have high performance, then we have to take a closer look again to the JVM, right? Because then I need to explain some points. So we saw already the 3 parts of the JVM, and this time we only would like to focus, on the execution engine. And if we take a closer look at the execution engine, we see the JIT compiler part and the garbage collector part. And these things you can really replace by other things, right? And so that means you could probably replace the JIT compiler by your own compiler. You can also create your own garbage collector and replace the garbage collectors that are in the JDK. And some of the distributions do that, and this is probably most of the times because of high performance. So I just have 2, which is Azul Platform Prime, where we not only change the garbage collector to our own Pauses garbage collector, but also to our own compiler. So we replace the C2 compiler by our own Falcon compiler. And the garbage collector, we have our own C4 garbage collector. And there's one other thing that is more or less faster than the rest, which is Oracle GraalVM Enterprise. But keep in mind, employee-based license. And they have a different compiler here, right? And the ability to create native packages or native images. And that gives them some kind of performance increase in startup time. All right. So one other thing, a faster JVM can really help you to reduce cloud cost, right? Just to think about it, because at the moment, a lot of people are figuring out that cloud cost is really a thing. And if you have a fast JVM that can do the same stuff that the normal JVM can do, but you don't need that many resources, then you can really save some money here, right? So this is really a big difference. Just keep in mind, faster JVMs help reducing cloud cost. Next point of differences is features. Some distributions come with specific features that others don't offer. And one thing which is still a thing, believe it or not, is JavaFX. And there are only two distributions that really, or two vendors that really come with JavaFX. It came in the past till JDK 8. Officially, it was dropped with JDK 11 as far as I know. So it was in 9 and 10. But the last LTS that got JavaFX bundled with JDK, it was never really part of the JDK, but it came bundled with it, was JDK 8. But after that, it's now only Azul Zulu, Bells of Liberica, and the Bells of Liberica NIC, which is the native image kit. So it's the build of GraalVM. These three distributions are the only ones that come bundled with JavaFX. So if you are into JavaFX or desktop development, then these should be your distributions. Of course, you can also install whatever OpenJDK version or build of OpenJDK and then additionally install JavaFX. No problem with that. But if you would like to have it bundled, then you can. These three distributions are the ones to go. This is one thing where we can make a difference when it comes to features. And the other one is ARM32. I mean, it might be a specific part, but Java is not that small in the embedded area. So especially in embedded, we all have ARM processors, right? More or less. A lot of this is ARM. So there's a good reason to have ARM32 builds. I mean, there's also ARM64 builds, but ARM32 is still there. And it's only Azul Zulu and Bells of Liberica where you can find builds for ARM32. So if you are working in the embedded space and you are working on ARM32, this is probably one of the distributions you should choose because it just works. Okay, next point, alternatives. Alternatives means this is builds of OpenJDK that come with more than the normal things, right? And that's interesting because I didn't put it under features, even I could have, but I think it's worth to take a closer look at these ones. So first of all, there's Amazon Corrado. And the reason why I put it here on the list of alternatives is that since I think beginning of the year, it comes with a new way of starting it up, which is called Snapstart. And Snapstart is in principle creating faster start or makes a faster startup possible through CRAC. CRAC is the coordinated restore at checkpoint. It's a feature that Azul implemented in the OpenJDK. And they use this feature in Corrado in combination with Firecracker to improve startup time of the AWS lambdas that really suffer from the more or less slow startup time of the JVM with its workloads. And this is the reason why I put it here as an alternative. So if you run, and usually you run it on AWS because it comes with Corrado, it doesn't have to. So we have customers, and you probably might heard of it, which is called Netflix, and they run on AWS, but they don't use Corrado, right? They choose Zulu from Azul because of the better support and service. So it's your decision, but you can also run other JDKs or other distributions in AWS if you like. So the next one that is a little bit different is Alibaba Dragonwell. It's not that famous in the Western world, but in Asia, where it comes from, it's more often used. So, and it comes with stuff like the standard and extended edition. And then it has a feature which is called JVM. And that's interesting because in the end, it looks like it's a build of things that, again, Azul invented in the past, which is now ready now in our Prime JVM. And this is, it tries to starts up the JVM faster by saving compile steps. And this is in principle what it does. But I have to say it's experimental because I tried it and it doesn't seem to really work that reliable, but they have that and it's a feature of Dragonwell definitely. Then they have something which is called Elastic Heap. It's a garbage collection feature that returns memory of the Java heap to the operating system if it's not needed anymore. This is also something that they made up. And I'm not sure if this is the reason why they don't have the TCK compliance in JDK 11 anymore, but one of these things is one of the reasons why it's not TCK compliant. And they have something which is the WISP2. It's a stackfold symmetric coroutine at JVM level. It's also implemented only in DragonWeb. So, and you can already see that even if you have a build of OpenJDK, and even if it is TCK compliant, it could have additional features as long as it doesn't, if it passes the test, all good, right? But then you can, as a vendor, you can add additional things to the JDK. Another one which is probably not really well known here is Tencent Kona. I was myself a little bit surprised when I was working on the Disco API, which is an API where we give you access to all the different builds of OpenJDK. You can download it from there. And when I worked on that, I stumbled upon Tencent Kona. I was like, Tencent Kona, what's that? And it's Tencent is a huge company in Asia, and they have their own build of OpenJDK, which is called Kona. And this is specialized on ARM. So they especially built that for ARM chips. And they also implemented Kona fibers in JDK 8 and JDK 11, which is a coroutine compatible with Loom. So that means they claim it's faster, so I can't really prove that, but they have some tests on their website where they say that the Kona fibers are faster than the Loom implementation that is in Oracle OpenJDK or in OpenJDK. And the interesting part is that they also have it in JDK 8 and 11, which is fine, right? So it's a different thing. You have to try it. I don't have any experience with that. Interesting was that I talked to one of our sales guys from Asia, and he told me that Tencent is huge in Asia. So, and I never heard of it before, because here we use it, usually not, right? So this is interesting. But that's not all. They also implemented ZGC, so the zero garbage collector for ARM, right, for the ARM architecture. And it seems to be not an easy part to do that, but they did that. So that means, because it helps them on the embedded devices. So Tencent Kona has support for these kind of things. Another alternative that I have on my list is Oracle GraalVM. And the obvious reason is that we have two different versions. We have Community and Enterprise Edition. Keep in mind, Enterprise Edition is now based on the calculation for pricing is based on employees, a number of employees. And it has a polyglot JVM or polyglot VM, I have to say, because it's a virtual machine that not only supports Java, but supports JavaScript, Python, R, and Ruby, and which is a totally different thing, right? So the JVM in GraalVM is just part of it, part of the polyglot VM. And it has the Graal JIT compiler, which is a replacement for the C2 compiler in the OpenJDK, in the execution engine. And this is completely written in Java. So the idea was the C2 compiler is quite complex and it's old. Doesn't mean it's bad. It's just complex and it's written in C++. But it's hard to maintain. And the idea was once to, if we rewrite that in Java, it's easier to maintain. That's the main idea. And that's one of the differences, right? And in addition to that, it comes with the AOT compiler, which makes it possible to create native images. And this is, at the moment, it's quite popular for microservice environments because it can create smaller footprints, right? So you create a native image that only contains all the classes that are really touched during the runtime of your code. And you can then start it just by double-clicking, for example, or you just start it in your Linux container, and it's fast because it's a native executable. It comes with other things that are not that good, like debugging and stuff like that, but it's a feature of GraalVM and it's famous at the moment, so that's the reason why it's on the list. So you can use that. The next one in the alternatives list is IBM Semaru. And the interesting part here is that, of course, we have, again, a community and a certified edition. Certified edition means the certified edition of IBM Semaru is TCK compliant. The community build is not. right? The reason for that is not that it's technically probably is the same as the certified one, but IBM has to pay for the certificate. So that's the reason why we have this different things here. And it has a totally different JVM. It's a JVM made by IBM. It's the so-called OpenJ9 or the J9 JVM. It comes with a faster startup and a lower memory consumption. So that means it might probably be a good idea to use Xamarin for microservices, if you like, right? If you are into this area and you use OpenJ9, then these are one of the things that could be interesting for you. And it also comes with the AOT compiler. On the website, it says that it is faster startup to dynamically compiled AOT code. I'm not quite sure what that means, because for me, AOT code is compiled before and not dynamically, but that's what it says. At least it comes with the AOT compiler, and which can really lead to faster startup. So, and OpenJ9 is known for having a lower memory consumption and faster startup than the OpenJDK. It also comes with a feature which is called Instant On, which is in principle the same that Crack does for OpenJDK, is Instant On for OpenJ9 or for Xamarin in this case. So it's a coordinated checkpoint and restore, right? So that leads to faster JVM startup. And it has a feature which is called JIT server, where you have one machine that provides the JIT compiler, and then you can use you compile the code just once and optimize it. And then the next time another machine connects to the server and forwards the code, it gets directly the compiled version back, right? This is the idea of the JIT server. With it's one machine, you can just pass some code to it, and then you directly get the optimized version by the compiler, so that the local version doesn't have to do the compilation and optimization. So it just saves time, right? That's the main idea. That leads me directly to the next alternative. You see, we have a lot of alternatives here, and that is Azul Zulu. Azul Zulu, first of all, is just a build of OpenJDK, but it comes with something that we implemented there is Azul vulnerability detection. And the different thing here is, and this makes it a little bit very specific, is the vulnerability detection is built into the JVM. So that means once you execute code, the JVM knows exactly what classes are loaded from which package, from what library, and we can check if this specific code is vulnerable or not, because we can check that against a web service where we have a database that contains all these vulnerabilities, and we can check if this version is vulnerable or not. And what it makes the difference here is that we can figure out, let's take it like that. If you have a scanner that scans for vulnerabilities, that can just tell you, oh, you use a library, and that library has a version of Log4j which is vulnerable. Okay, so it will raise a red flag. With the AVD, the Azul vulnerability detection, it's different, because we can even figure out if this library and this version of Log4j is even used at all. Because if the JVM never executes it, we can tell you, yeah, you have a dependency that could be vulnerable, but it will never be executed. So it's not used. So you might be on the safe side, but still be careful, right? We will flag you with the orange flag and say, you use something which is known as vulnerable, but you don't use it really, right? You just have the dependency to that. That's the difference here. It's a new product. You can check it out on our website. The next thing is, I already mentioned that, is Crack. It's coordinated restore checkpoint. And the idea is quite simple, and it comes in Q1. So now officially, finally, yes. What we do is, you can imagine you have a JVM, you run it, you run your code, and at one specific point, you create some kind of a snapshot. That's called the checkpoint. And in principle, it's the same that if you are a developer, you know that in the evening, you finish your work, you just shut down the lid of your laptop, right? You don't shut it down, the machine, you just shut down the lid, or you just close the lid. So once the lid is closed, the computer will detect, oh, the lid is closed. So that means I have to save the state of everything that's open. And the next morning, when you just open the lid, it will find the state on the hard drive and will restore it directly into memory. So that means you know that probably that if you have your IDE open and you just close the lid, the next time you open the lid, you have to log in, and then the IDE is still there. this is a checkpoint and the open is the restore. And we do the same thing on the JVM. So that means your application is running and a specific point you can define, now I would like to create a checkpoint. So it will save the state of the JVM, including your application. And then you can start from there. And that can save you money in the cloud because you don't have this high peak for CPU usage. And it's a very simple way to reduce the startup time to the same times that you can get with native images. So we can get down to 50 milliseconds for a Spring Boot application. And that's really fast, with the advantage that you still keep the JVM alive. So in native image, you don't have a JVM anymore, but with Crack, you still have, right? So this is an interesting feature. And also the AVD, the Azul Vulnerability Detection. The next alternative, and I think it's already the last one on my list, is Azul Platform Prime, which is a different JVM that we have. And this one comes with a so-called FalconJIT compiler. So we replace the C2 compiler like GraalVM does with the Java-based version. We replace it with the LLVM-based compiler that we wrote on our own, which is better or faster. It creates better code than the C2 compiler, and it's in general faster. It takes a little bit longer to compile, but the code after all is faster. And in addition to that, we also have our own garbage collector, which is pauseless, even on very large heaps. I mean, when I talk about very large, I talk about terabyte heap here, right? And still pauseless with a terabyte heap. This is possible with the C4 garbage collector, which is also part of the Platform Prime. And we have, that's not all, because I mentioned that Dragonwell uses this, I forgot the feature, but they have this thing where you can try to save the compilations and optimizations. Well, we invented that and it's ready now. And what we do is you can think about like the compiler is going, when it runs your code, it optimizes the code over time. And so the code gets faster and faster because it gets more optimized. So what if you just save all the optimizations and the next time you start up your JVM, you directly go to the optimized version instead of doing all the compilation again. So this is in principle ready now. Very simple explanation, but that's what it is. And it helps you a lot to warm up the JVM, right? Because it saves you all the time that was spent in interpretation, C1, C2. Here, we do that once, we record the profile and directly go. The next time we start, directly go to the compiler with the optimized version. And then we also got Cloud Native compiler, which is similar to this IBM Samaru. They have this WebJIT or web compiler. So what we do is we have a cluster. And in that cluster, we run a version of Azul Platform Prime. And that means there we have this compiler running. And then you can hook up all your microservices to this one cluster. And if you have code to compile and optimize, we can just pass, like, let's say it's like a footprint of a method to this web service, to this cluster. And then it directly returns you the optimized code. So that means the first time you call it, it optimizes it. It takes a little bit longer and returns the optimized code. The next time another web server or another microservice calls with the same footprint, or with the, don't say footprint, right? It's like a fingerprint of the method. The next time this cluster is called with the same fingerprint of the method, it will directly return you the optimized code, right? So that means you really save all this compilation and optimization on each microservice, because this has only been done once for each method. And it's even if it's the same method from the same let's say you have microservices, same code is running, the same method calls the cluster, but it was differently optimized because the usage was a little bit different. Then because we fingerprint each method, it gets a different optimization for both of them, and we store them. So that means this can really speed up if you have to scale out your microservices. That can really speed up this Cloud Native compiler, can speed up the execution. Platform Prime, I already explained that for Zulu. It comes also with vulnerability detection inbuilt, and I explained that already. And from Q2 this year, we also will provide Crack for Prime, which is the coordinated restore at checkpoint in Prime. So you see, we have all these different alternatives. They all come with these different features. And most of them, they are most of these alternatives are all TCK compliant. So that means you can use them in production without any big problems. But then you can make use of these different features that they offer. That leads me to the takeaway. We had this question, which one to choose? You saw it's a lot of different facts that I presented you. That's all I could figure out and present in 45 to 50 minutes. So the takeaway of that session is that are all those builds of OpenJDK really different? Right? Technically, not really. If it comes to service support and cost, probably yes. So choose wisely when you select a JDK. That's my advice. So I can't really give you an idea what you should use, but you saw that we have all these different JDK distributions, and most of them are just the same, more or less, right? Some come with different features. If you're in the need for different features like high performance, or you have to, fast startup time, we have to reduce the cloud cost, then there are different solutions that you can choose from. And I hope that helped you with your decision of choosing a JDK. And with this, I just say thank you for attending this webinar.
Perfect. Thanks, Garrett. I appreciate great presentation. We did have a question come in, so I'll just move into Q&A. So for folks who are still on the call, if you have any questions, feel free to type them into the Q&A box and Garrett will kind of answer them. So
should I type them in, or should I just give them the answer?
Sure. We can go ahead and just do it verbally. So Anbu asks, Amazon Corretto Snap Start, does it only work with Lambda?
That's a good question. I know that it was implemented to solve the Lambda startup problem. And I'm not sure if they make it available for other stuff, or if it's because I didn't try it yet. So I would assume, because it's part of Corretto, that it should also work with other stuff. But as far as I know, and I might be wrong, it's only in JDK 11 at the moment for Amazon Corretto. That's what I know. So I can't really give you a definite answer here. But you might want to look it up on the Amazon webpage, because there's a lot of documentation about SnapStart. If you just look for Corretto SnapStart Firecracker, you will find some stuff.
Awesome. And then you talked about the Oracle pricing, the employee count. Garrett, could you share a little bit more about that?
Yeah, it's interesting. They made a really interesting move I think in January, where Oracle changed the base for the calculation for the Java SE subscription. So usually you base it on the count of a number of cores or vCores that you have in production, for example. This is the amount, and then you calculate on the number of cores the price you pay for the Java SE subscription. And now Oracle made the decision that instead of using the cores or vCores, which is hard to figure out because for each customer, they have to go there and figure that out. They just decided, oh, wait a minute, we just go by the number of employees. Oh, that's a nice idea. So that means you have a company with 10,000 employees, 10 of them use Java SE, and you have a Java subscription. Bam, you pay for 10,000. It's really like this. And it's a little bit shocking, but yeah, hey, that's Oracle, and they do that. So I just can advise you, if you have a Java SE subscription with Oracle, you really should check that out, because even if it's now it doesn't apply at the moment for you, it might be in the future, because they have this strange things like, for example, JDK 17, which is the current LTS version. The support for that will end next year in September, as far as I know. And that means if you stick to JDK 17, next year in September, you will suddenly apply for the new licensing model. Oh, no, not licensing, that's wrong. The calculation for the Java SE subscription model. And that means it could be very expensive next year. So I can just advise you to have a look at that and talk to your people that are in charge of figuring out if you have Oracle Java SE subscription, because it could be very expensive. We heard about customers already. They contacted us because they got bills in the millions.
Awesome. Thanks, Garrett. Another question came in here with Nathan asking, what is the incentive for businesses to have their own JDK build?
Oh, yeah, that's a good one. that's not so hard to understand. So if you, for example, take Microsoft, they have Azure, which is their cloud service. And before they had their own JDK, they used the Zulu build from Azul. So they use that for all of the JDKs that they have in their Azure services. So if you run on Azure, I think it was before last year, you run on Zulu. But the problem for them was that they rely on us, and they would like to have it in their own hands. So they just decided they build their own JDK. So that's Microsoft build of OpenJDK, to be independent from anybody else. That's the main reason, because, and if you take a look at Amazon Corretto, for example, it's in principle the same, but they could also just add stuff like the snap start and crack thing into their JDK, even if it's not officially in the JDK, in the OpenJDK, right? At the moment, crack is just a project that we provided to the OpenJDK, but it's not officially part of OpenJDK. That means if you download, let's say, Tamarin, it doesn't have support for crack. But now the vendors can implement that. And Corretto or Amazon, they figured out that this is a really good thing to improve the startup time of Lambdas, so they added it to Corretto. That's the main reason why companies do that. They would like to have control over the stuff. They would like to add things. For example, Dragonware, they add their own stuff, or Tencent Kona, where they build ZGC for ARM. So because it's not available in the OpenJDK source code, they just build it and add it on their own. That's the main reason.
Great, thanks, Gerrit. Another question here came in from Padmavati. Is Azul Java compatible with SAP products?
Yes. I mean, SAP, as far as I know, is also TCK compliant, and Azul Zulu is TCK compliant. And that makes sure that as long as the SAP software doesn't really use something very special that is unknown in the SAP, it's called SAP machine. That's the JDK, OpenJDK build from SAP. But as far as I know, this is just a plain vanilla build of OpenJDK from SAP. So you should be able to run SAP products on Azul Zulu, for example. Yeah, should be possible.
Awesome. Great. So I don't see any other questions. So I think we'll go and just wrap up. Again, thank you, Gerrit, for your presentation. And thank you, everyone, for joining us today. We'll go ahead and send out the recording and slides after the webinar here. But thank you again, and hope you have a great rest of the day. Okay, thank you.